This is pre-calculus section 1.3, the second video in this section. And this one is on write an arithmetic sequence recursively and graph an arithmetic sequence. Write an arithmetic sequence recursively, and then we're going to graph in just a minute. All right, so again, the student objective, all of this has to be in your notes. Students will be able to write an arithmetic sequence recursively and explicitly. So in a different section, we're going to talk about explicitly. In this section, we're talking about recursively. The recursive, remember from the previous section, that recursive means we're defining the nth term by the term that comes before it, okay? So now, if a sequence is arithmetic, that means you're always going to take the term that comes before it. So the term that comes before the nth term is the use of n-1 term. Use of n-1 means the term that becomes before the nth term. So you're going to take that term and add the common difference. This right here is the common difference. Okay? And then that gives you the formula for any arithmetic sequence. Okay? Here we've got a problem. Let me scroll down. Okay, so there we want to ask 3 questions about an arithmetic sequence whose first term is 2.5 and whose second term is 6. So find the common difference. Well, here we've got 2 sequential terms, and it tells you that it's arithmetic. That means, you know, if I continue that pattern forever, I'm always going to add the same amount. So to find the common difference, I'm going to subtract the second term from the first term from the second term. So 6 subtract 2.5 gives me 3.5. So the common difference is 3.5. And we usually use the letter D to denote common difference. Write the sequence as a recursive function. Remember from section 1.2 that there are 3 steps to writing a expression recursively. You have to state the first term. All right, the first term is 2.5. Then you put a comma. And then we're going to state the nth term based on the previous term, based on use of n-1. And since this is arithmetic, we're always adding the same amount. How much are we going to be adding? We are adding 3.5. So this part right here is this formula, okay? Use of n-1 plus whatever the common difference is. The third step for defining a sequence recursively is to state the domain, and that's usually n is greater than or equal to 2 because we started with the first term. We started with u sub 1. So every term that comes after the first is n greater than or equal to 2. Give the first 6 terms of the sequence. Okay, well, I think they already gave us the first 2, so I'm just going to say 2.5 and 6. That's term 1 and 2. And then we're just going to keep adding 3.5. So now this is 9.5, 13, 16.5, and 20. I hope I did that right. All right. Now we're going to graph that sequence. Okay, so here, students will be able to graph an arithmetic sequence. Okay, here I've got the graph paper. I've got those same 6 terms. Let's see what the graph looks like. So the first term is 2.5. So we've got x coordinate of 1, y coordinate of 2.5. The second term is 6, so 2, 6. The third term is 9.5. And then 4, 13. 5, 16.5. And 6, 20. Okay. So we want to examine what this looks like, okay? This is linear, right? They do line up. Remember, when you're graphing a sequence, you're not connecting the dots. It's discrete. It is not continuous. All arithmetic sequences have linear graphs, okay? And so, again, we've stated before that not all sequences have linear graphs, but all arithmetic sequences have linear graphs. So if you always add the same amount to get the next term, then it's going to line up in a straight line. Why? Okay, well, what do we know about the change in a linear equation? That the change is always constant, okay? And that's what we've got with an arithmetic sequence. We're always changing it by the same amount, by the common difference. Okay, I think that concludes write an arithmetic sequence and graph it.